Okay, so there's something quite cool about our conjugate root theorem in that if we know that I have a complex root and all my coefficients of my polynomial are real, then the complex conjugate is also going to be a root of that polynomial. And I can then find all of the unknowns using some other information, and I can write that polynomial in factorized form. And it's quite a nice way of being able to do things. It gives us a few more little tricks up our sleeves. Don't get stressed out by this. It's actually pretty cool. So it says here, P of Z is a cubic polynomial. Okay, got real coefficients. That word's important because they're telling us that 2 minus I is a zero of P of Z. So that means that 2 minus I is a factor. And because I've got real coefficients and I've got a complex factor, it means that my complex conjugate is also a factor. Okay. They're telling us that when P of Z is divided by x minus 1, so that's going to be P of 1, the remainder is 6. And when P of Z is divided by x minus 2, so that's, oh, these must be Z's, sorry. These are Z minus 1 and Z minus 2. So that's going to be P of 2, the remainder is 5. So I've got some information using my remainder theorem, and I have enough knowledge to be able to put together some sort of a cubic polynomial. Okay, so they're telling me P of Z is cubic. So let's start with that. P of Z, if it's cubic, it's AZ cubed plus BZ squared plus CZ plus D. So I've got 1, 2, 3, 4 unknowns in my A, B, C, and D. Okay, and I'm going to need to find the values of A, B, and C, and D. So I'm going to have to find 4 different pieces of information. Okay, so I know if I were going to factorize any cubic polynomial, just bear with me here. If I had y equals ax cubed plus bx squared plus cx plus d, I could write that as a x minus x1, x minus x2, x minus x3. And hopefully you remember that from your methods course. I'm going to be using a similar technique over here. Just rub that out now to show what this thing would look like with its various factors. Okay, so using our conjugate root theorem, okay, I've been told of if 2 minus I is a factor, well then 2 plus I is also a factor. Okay, now P of Z is cubic, therefore it has 3 linear factors. So my x minus x1 times x minus x2 times x minus x3. So I can actually write this thing as P of Z is going to be Z minus Z1, Z minus Z2, Z minus Z3. Okay. And I could then write that. I know what two of these roots are. I know that that's going to be 2 plus I, and that one's going to be 2 minus I. And this is going to be some linear factor. I don't know. So I can write that as Z minus 2 minus I times Z minus 2 plus I times A Z minus B, where A and B are both real numbers. Okay, so I've now got a form for my cubic equation. Okay, and I'm using my roots because I've been given roots. So if I use my x-intercept form of that equation, I can work with it. Okay. Now, what else have they told me? Well, they've told me that if I substitute a 1 into every single value of z, my remainder is 6. Okay, so let's start with that. So using the remainder theorem, P of 1 is equal to 6. Okay, so therefore 1 minus 2 minus I, 1 minus 2 plus I, A times 1 minus B is equal to 6. And I can simplify that down a little bit. 1 minus 2 is negative 1 plus I times 1 minus 2 is negative 1 minus I. And that's A minus B is equal to 6. And I can expand this, becomes 1 minus I squared times A minus B equals 6, and I squared is negative 1, so 1 minus minus 1 is 2. So A minus B is equal to 3. Okay, that doesn't look too bad. Let's use the other bit of information we were given. So we were given that P of 2 is equal to 5. So I've been told P of 2 is equal to 5. That means that every single value of Z, I'm going to put a 2 in. So 2 minus I, 2 minus 2 plus I, A times 2 minus B, and that's equal to 5. Well, 2 minus 2 is 0, and negative times negative is positive I. 2 minus 2 is 0, negative I, and I've got 2A minus B, and I times negative I becomes negative I squared. I squared is negative 1, becomes positive 1, so I have 2A minus B is equal to 5, and maybe we want to write that as B is equal to 2A minus 5. All right, I've now got two equations in A and B. I'm going to substitute 2 into 1 so that I get A minus 2A minus 5 is equal to 3. So negative A plus 5 is 3, and so A will be equal to 2. And I'm going to substitute A equals 2 into 2 so that B is 4 minus 5, which is negative 1. Okay, now they've asked me to determine the polynomial, not to find the values of A and B. So therefore, P of Z is going to be z minus 2 minus I, z minus 2 plus I, 2z plus 1. And I need to expand that. So that becomes z squared minus 2 plus I z and minus 2 minus I z plus 2 minus I 2 plus I, and I'm multiplying that by 2z plus 1, and I can simplify this minus 2 minus I minus 2 plus I becomes minus 4z, so I've got z squared minus 4z, and this becomes 4 plus 1 is 5, and that's going to be my P of z. I guess I can expand it further to become 2z cubed plus z squared minus 8z squared minus 4z plus 10z plus 5, and that gives me 2z cubed minus 7z squared plus 6z plus 5.